Thanks for watching my video today. Let's try to evaluate this infinite sum, the sum from n equal to 1 to infinity, p to the n factor upon n factor sin nx, right? So here p is can be put any value, okay? Now solution, let a is equal to or sum 1, okay? Now let's make use of Euler formula, then is e to the ix equal to cos x plus I sin x. In place of this one sine, I will put this e to the ix, okay? So when we solve this out, then we are going to extract that imaginary part back, okay? That's our trick. Therefore s is equal to the sum from n equal to 1 to infinity p to the n upon n factorial e to the I n x, right? In place of sine, I have to put ix, right? Here x is nx, right? Nx. So which is equal to, now n and n common, so sum from n equal to 1 to infinity p e to the ix to the power n upon n factorial n. What is this sum? Okay, you have to see that. What is the sum of this one? So let's see our exponential series. E to the x is the sum from n equal to 0 to infinity x to the n upon n factorial, right? So if you put, let's say p e to the ix is, let's say x, right? I mean these two are just similar, right? The thing is that here n start from 1, here start from 0, right? Now let's try to start from 1, this one. So for 0, x to the 0 is 1, so 0 factor is 1, so 1 plus the sum from n equal to 1 to infinity x to the n upon n factor, right? So we want this one, right? So this is our sum from n equal to 1 to infinity x to the n upon n factor is e to the x minus transfer here, minus 1, right? So all this one sum will be as equal to e to the, this sum is nothing but e to the x. One is x, or x is p e to the ix, p e to the ix. Then this is our x minus 1, right? So e to the ix is again what? Let's split it again. E to the p cos x plus I sin x and minus 1, okay? Using this identity as equal to, now we know that we can break this exponent into product, right? Since this is plus, so we can put them into product. So e to the p cos x into e to the ip sin x minus 1, right? And for this part, e to the I, let's say this whole time is x, right? E to the ix again, we have to apply this again, right? So e to the p cos x common, right? And for this part, cos x plus I sin x, right? Cos 1 is our x, p sin x plus I sin p sin x, right? And minus 1 is here. So s is equal to, now multiply them, e to the p cos x cos p sin x and minus 1, this is the real part, and plus I e to the p cos x sin p sin x, this is the imaginary part, right? So we get our summation. So our sum is what? Sum from n equal to 1 to infinity p to the n upon n factorial sin nx is, sin is nothing but our imaginary part, right? So our imaginary part is this one, which is e to the p cos x sin p sin x. And we can extract for this the real part also. For real part, sum from n equal to 1 to infinity p to the n over n factorial cos nx is our real part. So real part is e to the p cos x into cos p sin x minus 1, okay? So that is our proof. And all this summation, okay, are useful when we deal with that integration, okay? We are going to use all these things in our integration, okay? So that's why I'm proving this summation part first, okay? That's it.